Hey, grade sevens, it's Mr. Smith. Okay, here's what I wanted to do. I wanted to follow up on what you just saw with the Ed puzzle. Um, with the fellow there, he's talking about ratios and proportions and fractions and cross multiplying. This is a big idea in grade seven, and you really got to do your best to understand how all of these things are related. Okay, so in the video, he talked about books versus days, right? Okay, and he set up this equivalence between books and days so that he said if your original ratio or proportion is one book every 2 days, then you can create, right, the equivalence. Okay, remember he used that number. So equivalence. That's a big idea in math, this equivalence. Okay, and we've talked about this. What does it look like? Let's say if you're talking about, just going to increase the pen width a little bit here. What if you're talking about like a recipe? Okay, I've talked about this. Like, let's say your original recipe calls for 1 cup of sugar. Okay, so 1 cup sugar. Okay, that's a G. For every 2 cups of flour. Okay. And let's say it's Mr. Smith's favorite cookie recipe. So obviously, making one single recipe isn't enough. Let's create a proportion or a ratio. So this is right now we've got a ratio written in fraction form. Okay, so we've got a ratio written in fraction form. These two concepts are pretty closely related. Okay, and you dive more into ratios in grade 8. But our ratio of sugar to flour is 1 cup. For every 1 cup of sugar, you got 2 cups of flour. Now let's say I wanted to triple this recipe. Okay, in other words, there's no way. That's an R. There's no way that a single recipe would make Mr. Smith happy here. I need to triple this. So I'm going to times this by 3. That's what tripling means. And I'm going to times this by 3. So now I'm going to have 3 cups of sugar. Okay, 3 cups sugar. And of course, I need to maintain my proportion. I need to maintain my ratio. So what would the cups of flour be? Okay, I'll pause here and let you answer that. Okay, so hopefully you got 6 cups of flour, right? The cups of flour always has to be double the amount of sugar, all right? Now, let's just, whether you're talking about books and days, sugar and flour, or even just fractions themselves, let's just have a look at a fraction. Let's do a different one. Let's go with, well, you know what? Actually, let's start with 1/2 because I always like to start with a benchmark, all right? And then from the benchmarks, we can go from here. So there's lots of ways of explaining equivalence and proportionalities and ratios. One is, Mr. Smith, I know these are equivalent. So one of the questions I would ask, how do you know these are equivalent? Well, Mr. Smith, I made this fraction 5 times. The original fraction of 1/2, okay, I made it 5 times bigger and made it 5/10. Okay, you guys should know this by now, right? So what's the other way? What's another way? You could say, Mr. Smith, I could convert this to a decimal, right? What's the decimal form of this? All right, so what's the decimal form of this? Okay, well, the decimal equivalent of 1/2 is 0.5. And we covered that in class the previous week, right? So 1 would go in your division house, and then 2 is outside. 2 goes and go into 1, right? Now lock in a decimal, bring down a 0, and 2 does go into 10 5 times. Okay? So the decimal, you could convert both to decimals. And what is 5/10 as a decimal? 0.5. Okay? So now you see the equivalence written as a decimal. Sometimes it's not so easy to see as a fraction because look, a different number. 1 is different from 5, different from 10, different from 2. But as a decimal, right, 1/2 is equal to a decimal. And that also means, guys, then if they're equivalent as a decimal, then they for sure are equivalent as a percent. In other words, we know that 1/2 is 50%. If Mr. scores 1 out of 2 on a quiz, that's 50%, right? And so we've talked about this. Okay, so the beginning of this review was just to give you a refresher, all right? Because now we're going to go into solving. We're going to use this cross multiplying proportion, equivalent ratios, equivalent fractions technique to help us solve problems, okay? So just to wrap this part of it up, let me set one up here. 2 over 5, okay? I'll pause the video here in a sec. Let's make this, let's make this 40. Okay, 40. Now, up here, I'm going to put here. What must the question mark be? What is it? What's the number that belongs here? Okay, I'll pause and let you answer that. Okay, so there's lots of ways of solving this. You could have just realized, well, Mr. Smith, to go from a fraction that's made into fifths, in this case 2/5, and to make it into 40ths, we're essentially blowing up this fraction. We're making it 8 times bigger. And so the equivalence would be, you know what, why don't we just take the number 8, right? 5 times 8 would give us 40. And if we're going to do that to the denominator, then we could do that to the numerator, and we could get that the question mark is equal to 16, okay? So in other words, 2 over 5 is the equivalent of 16 over 40, okay? Now, again, as a decimal, you can go back to converting everything to a decimal. Okay, this is 0.4, okay, that's a 0. And this is a 0, 0.4, I mean. Okay, so what is 2 divided by 5? Remember, 2 over 5 literally translated means, because fractions is division, is 2 divided by 5, right? 16 over 40 is 16 divided by 40. Okay, and in both cases, if you actually did that long division, okay, you would get 0.4. And that also means then, I'm just going to switch to a different color. Let's go with pink. So that means as a percent, right, we're talking 40%. Okay, you would multiply this by, you always multiply your decimal number by 100 to get your percent. Okay? And just to kind of wrap this up, that also means, you can just create a little choo-choo train. 2 over 5ths is the equivalent of 40 over 100. And that's the definition of a percent. A definition of a percent is any fraction that has 100 in its denominator. That is, by definition, a percent. Okay? Okay. So I'm going to pause the video here and set up the next couple of pages. But just a sort of a refresher on, what does it mean? Proportions, ratios, fractions, equivalents, okay? Okay, so here's what we're getting at, grade 7s. We're talking about a fraction proportion can be used to solve any unknown in a word problem involving percents, proportions, and ratios. We use a technique called cross-multiplying. Here's how it works, okay? Let's say I have a proportion here. And let's say it was 1 over 2. Okay, we're going to start simple, but of course, the beauty of this, the power of this will be when your numbers aren't so simple. Simple, I meant to say. So let's just say, okay. Now, I know that question mark is supposed to be replaced by a 5. You know that 5 goes there, right? But let's figure it out through cross-multiplying. Okay, so cross-multiplying. Here's how it's going to work. Okay, and I'm just going to abbreviate this so I don't have to write out the whole word. So you take the numbers, okay, I'm just going to decrease my pen width here a little bit. The two numbers that are diagonally offset, some teachers call this the butterfly method, okay? The two numbers that are diagonally opposite, they're going to be, you're going to multiply them, okay? So you're going to go 1 times, remember the dot, now we're going to use a dot to do multiplying. Okay, 1 times 10. And then the number you divide by, okay, let's use green. That's going to be the number that points at the unknown, okay? So you're going to divide by 2, and that's going to equal your x, your unknown, okay? We could have used an x here or an n. All right, so If some of you are more comfortable with me using the times symbol, I'll do that. So 1 times 10, in other words, divided by 2 is equal to, okay, the question mark. What is 1 times 10? It's 10. What's 10? Okay. So what is 10 divided by 2? Okay, well, it is 5. All right. So in other words, 1 over 2 is equal to 5 over 10. Okay, I just want you to look at this for a second. 1 over 2, saying it's equal to 5 over 10. Here's another way we know this is equal to 0.5. We know this is equal to 0.5. We know this is equal to 50%. We know this is equal to 50%. There's another way. This cross multiplying actually also verifies, or is a way of checking, okay, whether two fractions are equivalent. So let's start with the orange. Okay, 1 times 10. Does it actually equal? Okay, this is why they call it the butterfly, because it ends up looking like a butterfly wings. Does it actually equal 2 times 5? Okay, is this actually equivalent? So let's just, for the sake of colors, let's just choose to. Yeah, 1 times 10 is 10. 2 times 5 is 10. Okay, so this is a way of checking. All right. Let's do another quick example. Let's say I make the claim here of 11 over, I don't know, let's say 27. I want to make some numbers here that maybe aren't so easy for you mentally. Okay, and over here, I'm going to say 135. Okay, 135 and 55. All right. Now, what's one way you could do this? Well, you could just say, all right, well, Mr. Smith, it looks like from 11 to 55 is times 5. And does 27 times 5, does that work? Well, let's see here. 27 times 5. Okay, let's see. That's 35. Carry the 3. 2 times 5 is 10 plus 3 is 135. Yeah, that's one way. Another way of checking, and with bigger numbers, you get to use a calculator. So let's start again. Let's start with our orange. The two numbers that are diagonally opposite. So one fraction's numerator, okay, one fraction's numerator times the other fraction's denominator, all right, should equal the other fraction's denominator times numerator. Okay, again, there's your butterfly wings in orange and blue. So the other fraction's numerator times the other fraction's denominator. So 55 times 27. Okay, so let's pause and figure that one out. Okay, so what's the answer? The answer on both sides here is, what's 11 times 135? It's 1,485. And over here, guess what? Shocker, it's 1,485. Okay, we're not surprised by this at all. This is how these fractions, you could check these fractions are equivalent.